Okay, so good afternoon, students. Today we are going to discuss about the 7-segment display. So the 7-segment display main intention is to display the numerical values, and when to use the 7-segment display, that purely depends on your interest. If at all means the interest is nothing but if you would like to display your information for the long distance view, then you are supposed to go with the 7-segment display. But the drawback of using the 7-segment display is the power consumed by the the display is going to be more. If at all your embedded system is working with the battery backup, then definitely this particular 7-segment display is not suitable. Okay, but if there is a possibility that your embedded system is working with power supply, means there is no need to worry about the power consumption, then definitely go with the 7-segment display, because the displayed information can be visible to the person who is a little bit away from the display. They can easily observe the values, the information which you are displaying on the screen. But the drawback, another drawback of the 7-segment display is you can't display the what is that alpha values, means characters, alphabets. You can't display the alphabets on the screen, and also you can't display the special symbols on the screen with the help of the 7-segment display. That is another drawback of the 7-segment display. But if you want to display the alphanumerical values as well as the special symbols, then better to go with the LCD display. But the drawback of the LCD display is the persons who are a little bit far away from the display, they can't observe the information which is displayed on the LCD display. So that is the drawback of the LCD display. But the advantage is you can display the alphanumerical values as well as the special symbols, and also the power consumed by the LCD display is going to be less compared to the 7-segment display. These are the advantages of the 7-segment display. So based on these two, based on the information related to the 7-segment display as well as LCD display, you can decide which display is suitable to your embedded system. Okay, that purely depends on your interest and how you would like to use the embedded system, means whether the visible the information which is going to be observed by the user is a little bit near, not the far away, then better to go with the LCD display. So that purely depends on the how we are going to use the display. Okay, how you are going to use the display. But in this class we are going to discuss about the 7-segment display. Okay, 7-segment display. The name itself says that the 7-segment display means there are 7 segments are there, means the LEDs are going to be used as a segments in this particular display. So here we are having the different types of the LEDs. So here we are using the bar LEDs to form the symbol like this. We are using the bar LEDs to form the symbol like this. Okay, now. So using this particular structure, you can display any numerical value from 0 to 9. Using this particular structure, you can display any numerical value from 0 to 9. And these LEDs, each line is indicating one bar LED. Each line is indicating one bar LED. So when you are going for purchasing any 7-segment display in the market, they are going to ask you whether you are going to use the common cathode or common anode 7-segment display. Okay, that means when you are going to purchase, you should remember that whether your interest is common cathode or common anode. Common cathode 7-segment display is nothing but when you are taking the LED, light emitting diode. So here we are having the bar type LEDs now. So when you are taking the LED, obviously we are having the cathode symbol as well as the anode cathode terminal as well as the anode terminal. So LED is a 2-terminal LED. Okay, now cathode and the anode. If all the cathodes of these bar LEDs are tied to one point, are connected to one point, and the anodes are going to be used for sending the information, then that kind of 7-segment display is called as a common cathode. Common cathode means if all the cathodes of the 7-segment display tied together and anodes are accepting the information, anodes are used for sending the information to the 7-segment display, then that kind of 7-segment display is called as a common cathode 7-segment display. Common cathode 7-segment display. If at all these bar segments, these bar LEDs, anode is tied at one point, means all the anodes of the these bars are connected at one point, and the cathodes are used for the transferring the information to this particular display is called as a common anode 7-segment display. Common anode 7-segment display means when you are going to purchase the 7-segment display in the market, they are going to ask you whether your requirement is a common cathode 7-segment display or common anode 7-segment display. So that purely depends on your interest. Means if the information is available in terms of the active low signal from the any device, then you are supposed to go with the common cathode. So if the information is available in the active high signal format, then you are supposed to go with the common cathode. If the information is available in the active low format, you are supposed to go with the common anode. If if the information is available in the active high format, then you are supposed to go with the common cathode 7-segment display. Okay, that purely depends on how the output information is available for the 7-segment display. Okay, how the output is available for the 7-segment display. So that depending on that requirement, we may choose the common cathode 7-segment display or the common anode 7-segment display. So here, as I said, total how many bar LEDs are there? 1, 2, 3, 4, 5, 6, 7. So as the 7 bar LEDs are arranged in this structure, so it is called as a 7-segment display. And depending on the digit, a corresponding bar is going to be enabled. Depending on the digit, a corresponding bar is going to be enabled. Let us suppose I would like to display the 1, numerical 1. I may use the FE, means I may glow the FE and turn off the remaining bar LEDs. Or otherwise, I may use the B and C to display the 1. I may use the F and E, I may use the B and C. If I am using the B and C, the rest of the bar segments are going to be turned off, and only the B and C is going to be glow. And if I am using the F and E, these bar LEDs are going to be turned off. So there is a structure. Depending on your interest, you may glow any kind of group of segments, any group of bar LEDs. That will be the FE or the BC combination. Let us suppose I would like to display the 2. 2 means you are supposed to glow the 2, B, G, E, D, and you are going to turn off the C and F bars. Okay, C and F bars. So based on that, whatever the value would like to send, based on that value, respective bar segments are going to be enabled, and the remaining things are going to be disabled. So enabling and disabling can be done. Means we can interface the 7-segment display directly to the microcontroller, or by using the BCD to 7-segment decoder. By using the BCD to 7-segment decoder, one way is using the BCD to 7-segment decoder. Other way is directly you can interface the 7-segment display to the microcontroller. So what are the advantages and disadvantages? We will see them one by one later. But remember that. So this is the 7-segment display structure. So this is the 7-segment display structure. Means the bar LEDs are arranged in this structure. So depending on your requirement, the respective bar LEDs are going to be glow, and the rest of them are going to be off, so that the information is going to be displayed on the screen. So this is the 7-segment display structure. Now here, when you would like to display the numerical values, means in terms of the microcontroller case, we may call it as a BCD numbers. When you would like to print the BCD numbers on the screen, the BCD numbers are the 4-bit numbers. The BCD numbers are the 4-bit numbers. 4-bit numbers varying from 0 to 9. Binary coded decimal number, they are varying from 0 to 9. So when you are using the 4-bit number, when you would like to display the any number from 0 to 9 on the 7-segment display, you can't directly connect this particular 7-segment display to the microcontroller if you are going to if you are not using the proper connections. Okay, so because the 7-segment display is expecting the 7 lines as an input lines, because if we are going with the common cathode, then how many anode signals are there, how many anode terminals are there? So from each bar we are going to get one anode terminal. So total how many anodes are there? 7 anodes are there. But the information is available in the 4-bit format, not in the 7-bit format. The information is available in the 4-bit format, not in the 7-bit format. Okay, not in the 7-bit format. So to convert the 4-bit information into the 7-segment format, that is the 4-bit information is nothing but the BCD number. In order to display the BCD number on the 7-segment display, we are supposed to convert the 4-bit number into the 7-bit format. 4-bit number into the 7-bit format. To perform that particular decoding operation, we are going to use one BCD to 7-segment decoder called as a CD4511. So this particular CD4511 IC is the one which is going to be used as a BCD to 7-segment decoder or the driver. BCD to 7-segment decoder or the driver. What it will do means it is going to access the information in the 4-bit format and converts that particular 4-bit information into the 7-bit format. That 7-bit format is readily available to supply the information, to drive the information from the CD4511 to the 7-segment display directly. Okay, now so let us go for the CD4511. What is the pin configuration? If you see, this is the pin structure of the CD4511. So in this particular one, A, B, C, D, these are the 4-bit BCD number. So these are acting as a input lines, and we are having the some special signals like LT is nothing but the lamp test to test the display, and BI is nothing but the blanking. Blanking is nothing but in order to turn on and adjust the brightness of the 7-segment display, we are using this particular pin. And LE is nothing but the latch enable. Latch enable means when you would like to send the information from the microcontroller to this particular CD4511, that is going to be entered, means from the microcontroller it is going to be entered into the CD4511 only when we are enabling the latch enable signal. If you are not enabling the latch enable signal, then definitely, even though the information is transferred from the microcontroller to the CD4511, that is not going to be entered into the CD4511. It is just because you are not enabling the latch enable pin. So the latch enable pin plays a major role. When you would like to send the information, along with the information, you are supposed to send the LE signal, that is the latch enable signal. And after that, we are having the VDD and the VSS. Those are the power supply signals, and these are the output lines. That is a 7-bit output line coming from the CD4511. So based on the naming, we are going to based on this particular A, B, C, D, all those signals name. Based on that, we are going to interface this particular output block to the 7-segment display. So here, in order to display the information on the 7-segment display from the microcontroller to the 7-segment display, we are supposed to use the mediator to convert the BCD number into the 7-segment format. BCD number is nothing but it is a 4-bit number. So in order to convert the 4-bit number into the 7-bit format to display the information on the 7-segment decoder, 7-segment display, we are using the one decoder called as a CD4511. We are using the one decoder called as a CD4511. Okay. So let us see how to interface this particular 7-segment display to the microcontroller using the CD4511 is a question. So here I am using the this is the interfacing diagram. I am trying to interface the two 7-segmented displays to the microcontroller. So this microcontroller is using the 4 lines as a common lines. Means 4 lines as a common lines for the first CD4511 and another CD4511. Means how many number of 7-segment displays you are using to display the information, that many number of CD4511 ICs you are supposed to use in order to convert the BCD information into the 7-segment format. Okay, now BCD information into the 7-segment format. But if you are increasing the number of 7-segment displays, then only the CD4511s are going to be increases, but the number of pins which are coming from the microcontroller are not going to be increase. What we are going to do is we are going to make use of the same 4 lines, and we are going to switch the information from one display to another display to another display with a time delay, which cannot be observable by the a human eye. Okay, so that is the main intention. Means within a fraction of seconds, the information is going to be keep on transferred from the one display to another display. Because of that, which is going to be done within the microsecond range. So because of that, the naked eye cannot observe the information that only one display is displaying the information and the rest is not displaying the information. So that's the advantage. Means by giving short delay, we can send the information from one display to another display. So by seeing that one, we think that the information is not what I mean to say that when you are using the multiple displays at a time, only one display is displaying the information. That is what my intention. But that variation you can't observe by your naked eyes. So that is the advantage of displays. Okay, that is the advantage of using this kind of structure. Okay, so here CMOS CD4511 is accepting the 4 signals, and it is converting the 4 signals into the 7 output lines. This one is also converting the 7 signal into the 4 inputs into the 7 output lines. So these 7 output lines are given as an input to the 7-segment display. This is the one 7-segment display. This is the another 7-segment display. But if you see this one, only 4 bits are, as I said, only 4 bits are used to supply the information for the first display as well as the second display. So which display is going to be receives the information which is there on these particular port lines P10, P1.02, P1.3, to which display this information is going to be transferred. That is going to be decided by the latch enable pin. Here I forgot to write the latch enable. This is the latch enable pin for this particular CD4511, and this is the another latch enable pin for the this particular CD4511 IC. Okay, so means with the help of the latch enabling pin, we are able to send the information to a particular display, onto a particular display. Okay, so this is about interfacing your 7-segment display to the microcontroller using the CD4511. So what is the use of the CD4511? CD4511 is used as a BCD to 7-segment converter, or the BCD to 7-segment converter. In simple format, we call it as a decoder, BCD to 7-segment decoder or the driver. Okay, now so CD4511 is a BCD to 7-segment decoder. Okay, so which is used as a mediator between the microcontroller and the 7-segment display. The other way is, without using the CD4511 also, you can interface your 7-segment display to the microcontroller. Without using the CD4511 also, you can interface your 7-segment display to the microcontroller. But the problem is, in order to display the information on the screen, how many bits it is expecting? 4 bits. How many bits it is expecting? How many bits it is expecting? 7 bits. Okay. So means when you are not using the CD4511, these 7 lines should be connected to the 8051 microcontroller or the PIC microcontroller, whatever the microcontroller it is. But when you would like to interface the 7-segment display directly to the microcontroller, at that time from the microcontroller you are supposed to provide the 7 lines as the input lines to the 7-segment display. 7 lines as an input to the 7-segment display. So that is going to be a tricky point. Okay, now. So the complexity of the diagram is also going to be increases when you are not using the CD4511, because the number of lines which are going to be used by the 7-segment display is the 7 lines. If you are trying to interface the multiple 7-segment displays without using the CD4511, obviously the complexity of the diagram is going to be increases. If you want to see that one, which is there in our textbook, as per our textbook, so you can have a look. Yeah, we have both on the screen. So in this case, only 4 lines are coming from the microcontroller, and these 4 lines are converted into the 7 lines by the decoder, which is a CD4511. So in order to interface more number of 7-segment display, what will happen? 4 lines are going to be fixed one, but only the number of lines which are increased are the latch enable pins are going to be increased. As you are increasing the displays, the 4 bits are not going to be changed. Only the number of latch enable pins required to enable the CD4511 is going to be increases. But if you see this one, here what we are doing is we are directly interfacing our CD4511. We are directly interfacing our 7-segment display to the microcontroller without using the CD4511. When you are interfacing directly, then the complexity is going to be increases. Complexity of this particular interfacing diagram is going to be increases. As the complexity is increasing, then definitely the power consumed by the the embedded system is going to be increases, whatever the system you are designing, because you are going to increase the number of transistors also. As the number of transistors are increasing on the board, then definitely the power consumed by the board is going to be increases. So it looks like a little bit complex, but easiest way is this format. You may use this one or this one. That purely depends on your interest. Okay. So this is how how to interface the 7-segment display to the 7-segment display to the microcontroller. 7-segment display to the microcontroller. So in short, when to use a 7-segment display? If there is no power restriction and you would like to display the information, that is only the numerical values on the screen for the long viewers, then you are supposed to go with the 7-segment display. if there is a power restriction, then you can't go with the 7-segment display. You are supposed to go with the LCD display. What is the advantage of the using LCD display? Advantage is nothing but the power consumed by the LCD display is less, and we can print the alphanumerical values as well as the special symbols. Alphanumerical values as well as the special symbols on the screen. But the drawback is it is difficult for the long viewers to observe the information which is displayed on the LCD display. So this is how to interface the 7-segment display to the microcontroller. Okay, now. So the next topic is LCD display. Next one is the LCD display. So how to interface the LCD display to the microcontroller. So before studying about how to interface the 7-segment, what is that LCD display to the microcontroller, let us review some points. Means what are the advantages and disadvantages of the LCD display. So we have seen the LCD displays in our lab also. So if you are using your what is that a GM counter machine, on GM counter also you are having the what is that display. That display is nothing but your LCD display only. And you are having the microcontroller kit as well as the microprocessor kit. There also we are having the LCD display only. Okay. So the LCD displays are available in different sizes. In our lab case, we are having the almost 20 by 4 size LCD display, because we are having the 4 rows 20 columns. 4 rows 20 columns are there. 4 rows and 20 columns are there in our lab case, whatever the kit which we are using in our lab. So in the microcontroller as well as a microprocessor, we are having the same kind of LCD displays. But as per our syllabus, we are going with the 16 by 2 LCD display. The name 16 by 2 says that we are having the 2 rows, means the display is having the 2 rows information. You can display the information in the 2 lines format in simple way, not in the technical format. In simple format, if you want to know, the information can be displayed in the 2 lines format, and in each line you can print 16 characters, maximum of 16 characters. So 16 by 2 indicates that we are having the 2 lines. Each line is able to print the 16 characters. That may be the alphabets, that may be the numerical value, that may be the special symbol. 16 digits can be printed on each line. 16 digits can be printed on each line. So that is the size. Means when you are going to purchase the LCD module, we call the LCD display as the LCD module in the technical case. So when you are going to purchase the LCD module, you are supposed to give the specification like whether your LCD display is a 16 by 2 or 20 by 2 or some other size, depending on your requirement. But as per our textbook, as per our syllabus, we are going with the 16 by 2. But we have seen other size also in our lab. So we have seen the 20 by 4. 20 by 4 means 4 lines are there, and in each line you are able to print the 20 characters. In each line you are able to print the 20 characters, which we have seen in our microcontroller kit as well as the microprocessor kit. Okay, microcontroller kit as well as a microprocessor kit. Some other 7-segment, some other LCD displays you would have seen like GM counters. And GM counters also, that's LCD displays are installed for displaying the information. They are the 7-segment display, not the LCD displays. Some other kits are there; they are the 7-segment display, not the LCD displays. Now, so here we are having the LCD display. The advantage of the LCD display is we can display the alphanumerical values and also the special symbols. Alphanumerical values and also the special symbols. How to send the information to the LCD display, all those things we are going to study one by one. So when you are going to purchase the LCD module in the market, the basic thing is you are supposed to know the module size, whether it is the 16 by 2 or 20 by 2, 16 by 4, 20 by 4. That purely depends on your interest, means how you would like to print the information on the screen. Okay, how you would like to print the information on the screen. Let us go for 16 by 2 7-segment display, LCD display. 16 by 2 LCD display. Here I am going with one LCD display whose module size is 16 by 2. 16 by 2 means two rows are there, two lines of information you can print. In each line 16 characters are able to be printed on the display. 16 characters we can display on the screen. Okay, this explanation also we have seen during the microprocessor case in the third semester. We have seen this one during the third semester, but here we are going in depth in interfacing the LCD displays to the microcontroller. Okay, so here the basic pin description of our 16:2 module is here we are having the VSS and the VCC. These two signals are used for indicating the power supply. These two signals are used for supplying the power, to supply the power to the LCD module. And VEE, the main intention of the VEE is to control the contrast of the display. To control the contrast of the display, we are going to use the potentiometer. With the help of the potentiometer, this terminal is connected to the some voltage. So by tuning that particular potentiometer, you can adjust the LCD module screen contrast. LCD module screen contrast. Okay, so that display contrast you can adjust by using this particular VEE. And another one is in LCD module, means the LCD display is having some controlling block inside it. So that particular LCD module controller is accepting the information in two formats. Whether it is the information may be the data, the information may be the command format. Means we can send the two types of information to the LCD module to display your information. One is in the command format and another one is a data format. Command format main intention is there are rules and regulations, like let us suppose I'm having the 16:2 LCD module. I'm having the 16:2 LCD module. When you are having the 16:2 LCD module, when you would like to print the information on the screen, you are going to take some decision. So most of the people expecting that the information should be started from the left side of the display and keep on writing. Means it is just like the human beings who are writing on the paper. The information is going to be starts from the left side and moves towards the right side. Okay, moves towards the right side means for each thing where you would like to print the information on the screen, how you would like to print the information. So all those conditions are going to be available in terms of the commands. Means how you would like to display your information on the screen, whether it should be printed from the left to right side or right to left side, whether it should be printed on the first line of the display or the second line of the display, whether the information should be in the middle of the display or to the right corner of the display or to the left corner of the display. That entire thing is going to be decided and that entire thing is going to be decided, and that information is available in the command format. That command words should be transferred to the LCD display in sequential order. So if you want to see some of the command words, I think we are having the command words. Wait, I'll show that one. Wait, I'll show that one. I'm having on the screen. Yeah. So this is what the thing. When you would like to display the information on the screen, what will happen is you are supposed to take the certain decisions, and means how you would like to print the information on the LCD display. Whether the information which you are trying to print should be there in the first row or in the second row, and or in the middle of the first row or middle of the second row, or whether the information need to be printed from the right to left format or left to right format. That entire thing is available in terms of the command words, and based on the command words which you are sending from the microcontroller to the LCD module, that LCD module is going to be adjust itself in such a way that it is going to be print the information based on your command words which you are sending from the microcontroller to the LCD display. Some of the command words are 1, means when you are sending the 1 is in the hexadecimal format, means when you are sending whatever the command words which are there on the screen, they are the hexadecimal format. Code is in the hexadecimal format. When you are sending the 01 to the LCD module from the microcontroller, you are asking the module to clear the information, clear the display. Simple format is clear the display. And 02 is nothing but return to the home. Return to the home is print something and come back to the first column of the first row or the second row. That purely depends on in which row you are working. If you are working in the second row, then the information is going to become means after printing the information, the cursor is going to be comes to the home button. Home. Wait, I'll show you that. Okay. So assume that assume that this is my 16:2 display. This is my 16:2 display. 16:2 means first row, row 0, second row, row 1. So in each row, how many characters are able to be displayed? 16. So each row is having the 16 columns, simple format. It is also just like a matrix format. In each row, where the display is able to print the 16 characters. So I'm not drawing the 16, but I'm just showing a rough diagram. So information is going to be displayed in the column format. Now, the command words, sending the command words is purely depends on your interest. Whether you would like to print the information from the right to from the left to right format or right to left format in the either in the first row or in the second row. If it is the second row, then you are supposed to move either from the left to right format or right to left format. For this also we are having the command words. And after printing the information, whether you would like to bring the cursor to the home page of the corresponding row. What is that? Yeah, return to the home. Home line of this part means home is nothing but coming to the first column of that particular row. Simple cases coming to the first column of that particular row. How many columns are there? Total 16 columns are there. In the 16:2 display, we are having the 16 columns. In 20:2 display, we are having the 20 columns. Two rows, two lines. In each line, we are able to print the 20 characters. Means each character is called as a one column. Each character position is called as a one column. So where you would like to print the information, how you would like to print the information, that entire thing is going to be decided based on the command words which you are sending. So there are two types of command words which you can send to the microcontroller. There are two types of information which you can send to the LCD module from the microcontroller. One is a command word, another one is a data. Data is a simple data. Whatever the data you would like to send, that data should be transferred. Means if you would like to print the numerical value 3, then you can't send that 3 directly. You are supposed to send the ASCII value of that particular numerical value. Means, for example, I would like to print the 7 on the LCD module. If you are sending the 7 directly to the LCD module, it is not going to be printed, because whatever the character or whatever the number or whatever the special symbol you would like to print on the screen, that special symbol value, that special symbol information, as well as the character information or the numerical value information should be sent in the form of the ASCII values. Means the microcontroller should send the ASCII value of the corresponding character, ASCII value of the corresponding numerical value, ASCII value of the corresponding special symbol which you would like to print on the display. Okay, now so if you want to know the ASCII value of the each and every character as well as the numerical values as well as the special symbol, you are supposed to go to the data sheet of the corresponding LCD module. Okay, now so there are two types of registers which are there inside the these are the command words. So let me go back to the explanation of the LCD module. I'm not going to this. So we are in the discussion of the pin description, right? So inside the LCD module, we are having the two types of registers. One is a command register which receives the command. Based on the received command, it is going to be performs the operation on the LCD module. And another one is a data register. Data register means whatever the data you would like to print, that information is going to be stored inside the data register. In order to differentiate the data which is transferred from the microcontroller, in order to differentiate the information which is passing through this particular data lines from the microcontroller to the LCD display. Here the LCD display IC number is a HD 44780 Hitachi one we are using over here. So when you are sending the information through the data lines, in order to differentiate whether this information is a command word information or the data word information, that is going to be differentiated based on the RS signal. If at all the RS signal, register selection signal, RS is nothing but the register selection signal. If the register selection signal status is a 0, then whatever the information which is passing on this particular data lines, it is going to be treated as a command register, and the information is going to be stored inside the command register. And after that, if you are placing the information on the data lines and sending the active high signal on the register selection line, then the information which is there on the data lines is going to be treated as a data that is going to be stored inside the data register. And after that, we are having the read operation as well as the write operation. So read write operations means we can perform the read operation as well as the write operation on the LCD module. We can perform only one read operation and other things are the write operation only. Read operation means whether the LCD is there are two types of transferring the information. Two ways of methods are there to transfer the information to the LCD module from the microcontroller to the LCD. From the microcontroller to the LCD. One way is by generating some delay, means after every fixed delay, we are sending the information from microcontroller to the LCD module. Microcontroller to the LCD module. That is called as a without checking the readiness of the LCD module, whether it is ready to display or not. Without checking the LCD module readiness, we are keep on sending the information from the microcontroller to the LCD module. That is one method. Okay, now that is one method. And another method is, first of all, checking the readiness of the LCD module. If at all the LCD module is ready, then only send the information to the LCD module to display the information. Okay, now two methods are there. One is by using the fixed amount of delay, we are keep on sending the information from microcontroller to the LCD module. Another one is, in the first case, we are not checking the readiness. After means we are expecting that within that delay, the LCD display is working, it's performing its operation. We are expecting that the LCD module is performing its operation within that particular delay. And another one is checking the readiness of the LCD module. Checking the readiness of the LCD module, whether the LCD module is ready or not. If at all the LCD module is ready, then only we are going to send the information. Otherwise, we are not going to send the information. So whether the means the LCD module is going to be shows its readiness to the microcontroller with the help of the most significant bit of the data line. Most significant bit of the data line. So it is the 8-bit data bus which is established between the LCD module and the microcontroller. Based on the most significant bit of the data line coming from the LCD module, based on that line, we are going to check it out the LCD module readiness, whether it is ready or not. So two methods are there. Say keep on sending the information without checking the readiness by using the fixed delay. Another one is checking the readiness, send the information to the LCD module. Okay. So here we are having the only one read operation. Read operation can be performed on the LCD module. Only one type of read operation, that is nothing but the checking the readiness of the LCD module. Checking the readiness of the LCD module. The other operations, other than the readiness, other than checking the readiness, other operations are always the write operations. So in order to differentiate whether we are performing the read operation or write operation, we are simply using the RW signal. If the RW signal status is a 0, then we are performing the write operation. If the RW signal status is a 1, we are performing the read operation. One is a write operation, another one is a read operation. Next one is a enabling signal. Next one is a enabling signal. So here when you would like to send the information from the microcontroller to the LCD display now, inside the LCD display we have the latch. We have the latch. So whatever the information you are placing on the data lines, that information is going to be driven into the latch. From the latch it should be entered into the LCD module. But sending the information from the 7-segment from the data lines into that particular latch is going to be done based on the enabling signal. Means even though you are writing the information on the data lines from the microcontroller, it is not going to be received by the LCD module directly, because between the data lines coming from the microcontroller as well as the LCD module, we are having the latch. So that latch should be enabled. Whenever the latch is enabled, at that time only the information which is there on the data lines is going to be entered into the LCD module. Otherwise, it is not going to be entered into the LCD module. In order to drive the information into the latch, that is going to be done based on the enable signal. So enable signal is a high to low transition. Enabling signal is a high to low transition. Means if you want to send the information from the microcontroller to the LCD module, first of all you are supposed to place the data on the data bus and send one high to low pulse on the enabling signal, one high to low signal, high to low transition signal. So if I'm having the, all of you know this high to low transition, right? So if I'm having the enable signal like this, then on this signal you are supposed to send the high to low transition. Whenever there is a high to low transition, at that time the information available on the data lines is going to be latched into the latch available inside the LCD module. So that is the advantage of what is that? This particular enabling signal. And other pins are the data lines DB0 to DB7. So this is about the a brief pin description of the LCD module. One more time. VCC and VSS are nothing but the simple power supply which need to be applied to the LCD module to turn on the LCD module. And after that, VEE, the third line of the LCD module, is used to adjust the contrast of the display, LCD module display. In order to adjust the contrast of the LCD display, we are going with the VEE signal. And RS signal is in order to differentiate whether that information which is there on the data line should be written into the command register or the data register. That is going to be differentiated with the help of the register selection line. And after that is we are having the read-write signal, whether you are performing the write operation or read operation. In order to indicate that one, we are having the RW line. And another one is the enable signal. So in order to latch the information available in the data lines into the LCD module, we are supposed to send the enable signal, which is a high to low transition signal. And another 8 lines are the data lines. So let us see the interfacing diagram. So how to initialize the module that purely, as I said, when you would like to send the information onto the LCD module, you are supposed to take the decision how you are interested to display the information on the screen. Whether on the first row you would like to display the information, whether on the second row you would like to display the information, whether you would like to display the information in the middle of the row or at the corner of the row, either to the left side or right side. So you are supposed to take the decision. That entire decision, and depending on your requirement, you are supposed to send a sequential order of commands from the microcontroller to the LCD module, so that it is going to be displays your information based on your requirement. You are supposed to send a sequential command words from the microcontroller to the LCD module. And another case is when you would like to send the information, the command words. So if you want to know that one, you may use the data sheet of the 7-segment data sheet of the LCD display, or any microcontroller textbook. You are going to have that particular interfacing now. So from there you can get the command words. So which command word is doing what kind of operations. Okay, now all those things depending on your requirement, you can choose appropriate command words, and you can send that command words from the microcontroller to the LCD display in the sequential module. And another case is, as I said, whatever the information you would like to print on the screen on the LCD module, that information should be sent in the ASCII format. Let us suppose I would like to print the number 6. I would like to print the number 6 on the LCD module. If I am sending the 06, on this particular line, it is not going to be recognized by the LCD module. Okay, now if at all there is a equivalent ASCII value, means if at all there is a this particular 06, whatever the 06 which we are sending, if that one is the ASCII value for some other element, then that value is going to be displayed on the screen, not your 6. That value is going to be displayed on the screen, not your 6. Okay, now, so means if you want to send the 6 onto the 6, if you want to send the information 6, that is the numerical value 6 from the microcontroller to the LCD module, you are supposed to send the ASCII value of the 6. We know the ASCII value of the 6, which is nothing but the 36. If you are sending the 36 from the microcontroller to the LCD display, then 6 is going to be displayed. So if you want to display the 39 you are supposed to send, because the ASCII value of the 9 is nothing but the 39. Like that, for every alpha numerical value as well as a special symbol, there is an equivalent ASCII values there. If you want to know those equivalent ASCII values, you are supposed to go through the data sheet of the corresponding LCD module. Using that particular data sheet, you are going to come across the ASCII value for each and every digit. That may be the alpha characters, or that may be the numerical value, that may be the special symbol. Okay, for all those things, equivalent ASCII values are there For that, you should visit the corresponding data sheet. Okay. So like this, you can send the information. And one more time, again I'm saying that when you would like to send the information, you are supposed to take the decision, whether it is in the first row, second row. If it is in the first row, at what point you would like to print the information, whether it is a left to right type of printing information or right to left printer. So that purely depends on your interest. So by taking the decision on how to print, at what area you would like to print on the screen, after taking the decision, you are supposed to write the sequential command words. You should send those command words from the microcontroller to the LCD module. So in this class, we are not going to write the program for the displaying the information, transferring the information onto the LCD module, displaying that information on the LCD module. In the next upcoming classes, we are going to see the programs if you are interested. Okay, so let us see how to interface the LCD module to the microcontroller. So this is the way of interfacing the LCD module to the microcontroller. So here what we are doing from the LCD module from the LCD module we are having the 8 data lines. And one ground line is there, 2 power supplies are there, and 3 controlling signals: RS, register selection, enable signal, read write signal. So this is the interfacing structure. You can interface the LCD module to any microcontroller. That may be the PIC microcontroller, or that may be the 8051 microcontroller. We least bother about which microcontroller is there on the board. We are only bother about whether we followed the rules and regulations while interfacing the LCD module to the microcontroller. It's a question. So this is a way of interfacing the LCD module to the microcontroller. So if you take this diagram, based on this diagram, in the next coming classes, if you are interested, then we will see the the program. We'll see the program, how to send the information from the microcontroller to the LCD display, and how to display the information on the LCD display. We are going to see that. Actually, in our lab, as we don't have the chance, I have a microcontroller kit of my own. So that particular microcontroller kit, you can display the information on the LCD module. Depending on whatever the information you would like to send, you can easily send that information. That entire thing is there in my developing board.